Good morning. Welcome to the S2S4E Energy Day. Last year, we were in Brussels at the European Sustainable Energy Week for the official launch of the S2S4E operational climate service. However, this year, due to the circumstances, we are glad to have you here anyways online. And we are having this Energy Day, as part of the European Sustainable Energy Week. We will have 3 sessions throughout the day, and from different parts. They are from different parts of Europe. We are now starting with our first section on visual communication of forecasts for renewable energy. And from Barcelona, we have our speaker, Isadora Jimenez. Isadora is a science communication specialist at the Barcelona Supercomputing Center, where she leads a multidisciplinary team specialized in knowledge transfer for climate services. For the last 5 years, she has been highly involved in the development of climate services for renewable energy and with a close collaboration with stakeholders in the sector. We have also here Andrea Marique with us. She's also a climate scientist from the Barcelona Supercomputing Center as well, and she has expertise in subseasonal climate predictions. She holds a PhD in meteorology from the University of Reading, and from the last 3 years, she has been working on the development of methodologies to assess the quality of probabilistic information, climate prediction within the multidisciplinary team of the Earth System Services Group. Andrea is here with us to answer any technical question that you may have today. I'm Ilaria Vigo. I'm an environmental economist, also at the Barcelona Supercomputing Center, and I'm part of the S2S4E project team. The 3 of us are working closely with renewable energy companies that are using climate services. Before passing the word to Isadora, I'm going to introduce you briefly to the S2S4E project. So, as you know, more renewables means more dependency on climate variability, which is increasing due to climate change. So the goal of the S2S4E project is to deliver climate information and ultimately supporting the increase of the share of the renewables in the energy mix. How we're doing so? Well, in particular, the S2S4E project offers climate predictions from 10 days to 1 month ahead, called the subseasonal forecast, and from 1 month to 3 months ahead, called seasonal forecast. We have been developing an operational climate service, the decision support tool, providing climate predictions for wind, solar, hydropower, as well as energy demand. Just a technical note before we start, you can post questions in the chat at any time. We'll try to answer during presentations as well as in the Q&A session after the presentation. So with this, I leave the floor to Isadora to discuss the challenges of visualizing climate forecasts and how this was addressed in the development of the S2S4E decision support tool. Thank you, Isadora.
Thank you, Ilaria. Good morning, everyone. So, yeah, well, as Ilaria was explaining, this project S2S4E is working specifically with climate predictions. And one of the points is that climate predictions are probabilistic. And so one of the main challenges to communicate them visually is how to deal with uncertainty. But what each of us understands by uncertainty is very relative. So if you ask climate scientists, this is an example of a definition from a project called Euphoria. It says that uncertainty is related to the exact value for a given time when it is not predictable. And then it enters into a lot of justifications, explanations about how there is knowledge on these uncertainties. But on the other side, for users, the definition is much more clear. So uncertainty is a situation which involves imperfect or unknown information. And of course, if you're talking about probabilities, there is unknown information because you don't know exactly what is going to happen. Then there's another word commonly used in climate predictions, which is reliability. And for climate science, most of the forecasts are highly reliable because they have a very specific and quantitative definition. So to make it a bit clear, reliability on climate science is if there's an event that is predicted with 70% probabilities, the forecast system is reliable or should be correct if it tells you the right forecast 70% of the times, which means there's a 30% of the times that the forecast is not telling you what already happened. Again, for users, there is just one definition. So reliable is someone or something that is reliable, that can be trusted or believed because it behaves well in the way you expect. And I start with this to emphasize that the challenge is not only how to communicate visually this forecast. I'm going to be practical in this webinar explaining about this, but the challenge is how to be able to communicate to different communities with very different perspectives and baseline assumptions. So the real challenge is how to build trust on the information displayed. And for this, I know it's a bit of a preamble, but I also like to emphasize that there's it's important to keep in mind that when we talk about users, and I will be doing it's natural and short, there is an automatic idea in our minds. So they are people expecting our results ready to use by them. So it's this idea, it's like they are in a bus stop waiting for us. But they are not just users, they are decision makers, which makes that they have to handle with many other sources of information they need to take into account. And climate forecast is just one piece that has to fit in the broad picture, in the broad puzzle. It's just another piece. Also, there is not only one type of user or one type of decision maker. I put here two extremes, from a CEO of a company to an energy trader, but in the energy sector, in renewables, there are many types of professionals. They have to make very different decisions. They have different amount of time to make decision, and the implications of what they do, it's really totally different. So it's key to understand the profile and also the motivations of these decision makers, users, to use the forecast before even trying to design a tool or finding a visual solution. And for this webinar, we wanted to get the chance to go a bit deeper in our experience while creating the decision support tool of the S2S4E project. And the idea was to share with you some insights on how we manage to communicate uncertainties in this visual tool, which were the visual solutions that we were doing. And so that at the end, it was doing a bit more practical, not focusing that much on the forecast itself, although we have Andrea to help if you have a bit more technical questions. We remind you that at 12, there will be this seminar all about the forecast in summer, but we wanted to focus on the part of how we are communicating these forecasts. And for that, I like to be bold, and I like to go to the browser, and I hope everything is gonna work fine. Then I invite you to register to the tool. So it's easy, you go register, there's a few information. The tool is free to use, but the idea is that you register so we know how many people is using it and accessing. You can be browsing it, using it while I'm talking if you prefer. So this way you will see in action a bit what I'm explaining, and also later if you have questions, then you will see. Before going into a bit of the details, I wanted to present you a bit the interface, so you know a bit what we are talking about. And what you have first in the upper side, you will see there is a general selection panel where you can either search a region that you're interested in, let's say Norway. So you could just zoom it. Now I'm showing only Europe because this is aggregated data for Europe, but the forecasts provided are global, you will see. So you could just go to any part of the globe. You could go to New York, Africa, whatever. Then you choose the forecast that you want to show. So by default, it's showing the last prediction, but you can really move to predictions from previous years. It could be loading. and showing, or you can go to the last prediction. And then this is one of the key features that one of the main aims that we had for this tool was providing sub-seasonal and seasonal predictions. So we wanted to provide a tool where the user could just choose to see what is going to happen in the coming weeks, in 1 week ahead, 2 weeks ahead, 3 or 4, but also what was going to happen in the next month, in 2 months ahead, and 3. And what it was key for us was really to provide the users the capacity of moving through these 2 forecast systems without having to bother on the idea that they are different or they are providing different information. On the technical side, there's a challenge on how to put this information, because they are not exactly the same systems. They have different rules. You have to analyze a lot. But then we wanted this to be transparent for the user. And besides this upper panel, there is in the left side, then there is the selection panel. So here you can choose the general categories you're interested in. So you can choose wind, solar, hydropower, or energy balance. We could choose hydropower. And then you can choose the variables that you are interested in. For example, let's say precipitation. And here you see, before I was showing aggregated data, and here you see gridded information. You could see precipitation, or you could see, for example, by country, similar to what we were seeing before. Then we get to a part with filters, which is, I'm not going to start now because this is the key part on how we were dealing with uncertainty with this tool. But just there are 2 options. You can show skill, you can show probabilities. I will be explaining later. And then you have some other customization aspects, like showing a dark map. And then something that is really important in the whole tool, and it's also part of the visualization, is first how to guide the user through the tool. So for example, there is a guided tour. When you register the first time, you see it by default, but you always have it available. And then, of course, an advanced information. Once you start going deeper, if you want to know exactly what are you seeing, which is the data sets that are being used, then all this information is available. Also, when you click in this small information icons, then you get a bit of a description of what you're seeing there, what it is available there, so you understand a bit how it is. And also something quite basic, which is this hover option, where you get a tooltip easy to tell you what you are supposed to be doing. Of course, as any map, you have a legend. You can collapse, or you can have it, and you have the map itself. And if we look into precipitation, which is that we are seeing now, what we see are mainly the baseline map and 3 colors. So we see that we can have data or countries that are in blue, in orange, or in gray. This is related to the prediction, the forecast itself. So what we provide is the forecast for tertiles, is the forecast of the probabilities of being on the average, like what you could consider normal for that country, above normal. So if precipitation is expected to be more than usual for that region, or below the average, which would be in orange. Once you click in one particular point, then you get in the right side a detail panel. And the detail panel is where you get more insights on the forecast. The color is just the fast indicator of what you could expect. So more precipitation in southern countries, less precipitation in the Nordic countries. But then you can see with how much probability, and then you get insights. And this, I will always be referring like this, like the detail panel. But then there is an advanced panel, which is where you go a bit further into the information that you can get available in this panel. And just to show you the advanced panel full, so this is all that you can see, and I will be going later. Then I see a few questions. I don't know if this is the general structure of the interface. I don't know, Ilaria, if anyone has an interesting question, just let me know. If not, I will go on.
Yes, Isadora, thank you for asking. Actually, we have someone asking in the left side of there is a download button. The sample data page does not work. So someone is testing it, but is asking about the download option.
Yeah, one of the things that is more important for the forecast is, okay, you provide a tool, it's something interactive, but then the next question that most of the users ask us is, okay, but where is the data? Where can I play? I'm an advanced user, I want to get. So that's why both here, also in the detailed panel, you see download options. So in the download options, there are two things. There's the Outlooks page. So when you click here, what you see are the outlooks that are provided every month, and I invite you to check a bit of them. And then there is this option of sample data. So initially we were thinking on providing access so anyone could download the global data set, the global forecast, but at the end, the amount of data is massive. So what we are going to do is to provide in the website of S2S4E a sample file, so you can really see a bit how the forecast behind the tool look like. But this is going to come in the coming weeks. So yeah, if you want, let's say, give us a few weeks and it will be available. But eventually, this is something that everyone asks, and we are open. So some users, they just contact us, and then we provide this sample data set so they can play around and understand better the forecast. And the idea is to make this for everyone without having to send an email and request for the data.
And I stop you for another question as well. We have Victor Fiago asking, when the forecast is presented as a percentage, is it compared to the same period for the last 30 years?
Yes, exactly. So it's always, if here we are seeing subseasonal forecast, this is for the week of the 8th of June to the 14th of June. So this percentage is compared to exactly that same period over the last 30 years. So yeah, it's always compared to the reference period.
Thank you, Isadora, and thank you for posing questions. Please go ahead if you have more questions.
So now I'm going to the part of the uncertainty. And one of the things, this is the question that we get from the users, and is, which forecast should I use? So yeah, should I use your climate predictions? Should I go with business as usual and trust on my observational data sets? How do I decide what to use? And for this, and let me just, this way I keep showing you some different, okay, we keep with wind speed, not aggregated. For this, in climate science, basically we use the skill scores. So the skill scores is the mathematical calculation that compares the performance of the forecast with the performance of a forecast based only on climatology. Climatology assumes there is 33% probabilities of being in the average, 33% probabilities above and below. And as business as usual, you assume that you're going to have normal conditions. I mean, later, of course, there's more complexity on, you can put more information, but ideally, that's what climatology tells you. So skill compares if over the last 30 years, if using the forecast would have been better than climatology. And for this, we have, if the skill is 0, climatology and the forecast work exactly the same. If the forecast is negative, then using climatology is better. Any skill score above 0 means that the forecast is slightly better. A 100% skill score, it could be a perfect forecast. And as you see, of course, there is no perfect forecast. But as you get, you play around with the level of exigence that you have for your forecast, you start filtering the information. One of the things that we highlight for the visualization is that, for example, we had to go for percentages. The skill goes from 0 to 1. But at the time of explaining, some users were really used to the concept of the skills, and some other, they really had problems understanding the skill. And this is small change, I mean, harmless change of putting percentages really help people to understand. It's more easy to understand 18% improvement than 0.18 improvement. And the simple fact of being able to filter the information is really a change in how you manage. Even it has been a change for the scientists in the team. Being able to play a bit around and having this interactivity with the data helps you find patterns that you couldn't imagine before. But at the same time, there is information also in the parts that don't have skill. And for that, we had to take that into account. So we put this view all option. And this view all option really provides you all the forecasts, no matter, for example, if we go to this point in Russia, if they have a skill or not. So let me just switch here. Let me find a place where we don't have so much skill. So for example, of course, as we go further in the future, then there are regions that have less skill. So you see here, for example, for August, it's not that clear. Well, it's fair enough, but if we go, for example, with temperature, then you will see here, we really start having gaps in the map. So maybe you could like to know which is the pattern. So if you can put the view all, then you will be able to choose a place where there is no skill, but you would like to know what happens with the forecast and whatever. So this is empowering the user of the tool. We sometimes have this temptation of controlling, and okay, I'm not going to show this because this skill here is not good, so I'm not going to show. But okay, this is the decision of the person using the tool. And also we have to understand that professionals in the renewable energy sector, they don't make decisions, bold decisions based on what you tell them. Your information is part of the puzzle, as I was saying at the beginning, and that's why the more information they have, the better. Anyway, it depends on the user. Some users are really advanced, they can control, others not. And what we were also trying when providing this skill, when you go to this more detailed panel, you see here a name. So here we were given a qualitative scale that this skill was fair. So, okay, it's better than climatology. If it was below 0, we really signal that they have to use climatology. And then we were signaling like good or very good the skills. So it was trying to adjust to different levels of users. The one who really want you to make the decision can just read, okay, fair skill, that's fine. Or they want to know the number, or they can have more access. Then the other aspect is for visualizing the forecast. So when should I use this forecast? And then, okay, now I know when there is a skill, I should see the forecast, but what about the probabilities? And for this, we really have this part, the probability threshold. And our idea here was a simple one. So you have the map, you have different dots, you know the colors. So you know here for temperature, for right now is the forecast for this week. We know the area of Russia, the temperature is expected to be above the average, below the average. But if you have 50% probabilities of being above the average, that basically means that you have 50% probabilities of happening exactly the opposite. So the idea was, what if I'm more exigent? I can do nothing. I cannot make a decision with a 50% probability, but maybe I can make a decision with a 75%. And here, as you see, then your information is more filtered. So now you're able to see, for example, region around or close to Barcelona, you see that there's 84% probabilities of having temperatures below the average. This is closer to what you may need. So at least it signals you some regions or some areas that are relevant. Or for example, if you go to somewhere in Sweden, then for example, you see that temperature has 78% probability of being above the average. And you could even be more strict and just say, no, I want to see 90% probabilities, or just to move to a different map, for example, in just 1 month, then maybe there's nowhere when you can see 90% probabilities. The rationale behind was empower, again, the user and allow them to set the threshold of when this tool can provide something that is relevant for them. And then for this, first is the skill, but particularly is the probabilities. Before going to another part of probabilities, I don't know if there's any other question.
For the moment, we don't have further questions, so
Perfect.
we can move to.
Yeah, no, I go ahead. So there was one extra thing that when we were having conversations with users when preparing this tool, okay, it's about probabilities, it's good to have the threshold, but the main keyword for people in energy, but also for people in society in general, are extremes. This tool is not focused only on extremes, it's not an early warning or anything like that, but we wanted to see how in the information of the forecast, where there was information that was related to extremes. So for example, you see when you decide to show extremes, you see some triangles showing in the map. Again, what it shows this, if you go to the detailed panel, you will see there is 84% probability of being below the average, but then there is this section about extremes. Here what you see is that you have 33% probabilities of having temperatures below the P10. This is that if you look in the past for the last 30 years, there's only 10% of the time you had temperatures as low as what it is forecasted. This 10% could be the normal probability, what you would expect only by chance. But then here you have 33%. So you have 3 times more probabilities than what you would expect in a normal situation. And specific to this value, we also provide the skill. And you see there's a 46% of a skill, so it's really a very, very good skill. So this is like a next point on how provide for a probability. So your first layer of information is you use colors to show the category. Then you use the size of the ball in order to highlight those regions with a very high probability. But then you start focusing in that particular part of the below average temperatures that is really relevant for your user. You talking about P10, P90 is a standard. So depending on the community, you have to explain what P10 or P90 is. But in this case, it is straightforward for anyone in energy what we are talking about. But even when you start giving the number, you can go even one layer deeper into how to provide information. And we were requested to provide the distribution of all the simulations. So a climate forecast is an ensemble of simulations. They have small changes in the initial conditions, then the model is run, and then we see all the simulations where they fall. And according to this, we can calculate the probabilities. But then seeing the distribution of all these members really helps you have an idea of how these are distributed. And even further into this, I think it will go to, if I go to seasonal forecasts, let's see if I have one a bit higher. I'm doing a bit of trick, but I want to show you signals that are stronger so you understand. You see here, we get a part that has the capacity of the extreme is 35% probability. The probability overall to be above the average is 80%. Then you see here the distribution. But then if you go to this more advanced, then you can also show climatology, and then you see how what the forecast is providing differs from what climatology expects. In this case, this curve is quite flat, but it could have different shades. But then you really see how the probabilities are displayed compared to what you could be expecting. So
regarding the streams, we have a question. Maybe Andrea can also add to this question. And it's just to be sure, how do you define an extreme? If it is lower than P10 and above P90 percentile from the last 30 years? Andrea, can you?
Yes, hello. Yes, exactly. So the threshold for the extremes is defined as the 10th or the 90th percentile of in this case, is the hindcast period. So for the subseasonal forecast, it would be the last years, and for the seasonal forecast is about 25 years.
Thank you, Andrea.
Perfect. And just something that, just to highlight, in this case, when we talk about the general terciles, then we are providing the probabilities for terciles. When we provide the probability of extremes, this could be a different case. In this case, we have only two categories: above P90, below P90, or below P10 and above. So this is really like having two categories compared to this one that has three. Also, just to show you, if instead of temperature, we show a temperature aggregated by country, what you will see is a bit the same. You have the colors, but then you see what we have here. Maybe you saw at the beginning, we have these points. This works exactly the same, that changing the size of the ball, and technically it's called glyph. So this way you can really highlight also, even if you're seeing a polygon, a whole country, if you see if here the probability is above the threshold that you are of interest. It works the same, but you have to find different solutions according to the variable. And just to show, if you go to hydropower, then we show, for example, inflow anomaly. Then it could be a particular case of having a forecast for a whole region. And it will take time because it is slow. Oh, I move it, sorry. So here, what you will see is the same concept of polygons, but in this case, we are not talking about countries. We are really talking about the sub-basins that are providing water of each of the big basins. But again, you would see, you could be more exigent, say, show me 75%. And then it could be showing the dots only in those regions that are, in this case, the probabilities are much higher. Then one of the things that, so skill and probabilities really are like the stars of the application, what all users were referring to, what all users wanted us to be able to manipulate and do. But then there is this other aspect, which is, can I trust these forecasts? And yeah, a skill, somehow should be this measure of a skill, it should be this measure of trust, but it's the measure of trust for climate scientists, which not necessarily is a measure that a particular user in the energy sector should need to trust on it. And for this, just let me go. We can go, but we can keep with wind speed. The point is how to provide users with the tools to start building trust in the tool, further than understanding which is the skill, score, how we calculate, etc. For this, one of the key aspects that we got from the feedback with talking or interacting with users was, okay, just show me this forecast in key periods in the past. I really want to know how this was performing. And here is where there was this functionality of being able to go years back and or going, for example, a few months back. So let's say, this January, I really know something interesting happening, and I would like to know exactly in that month, particular month, what, let me go. Let's wait. Yeah, well, subseasonal now. No, I think I have to refresh. Okay, now we are back again. And so one of the options was to be able to go 1 month behind and be able to see the difference in the data. Let me show, because, okay, now it is more obvious the change. Or maybe even go 1 year, 2 years, go later. Of course, this functionality, this takes time, because then you have to update and put all the data back again. Now I don't know what it is not showing, but let's say you put another year. So this is the last year, June last year, and you could see the forecast. The idea is this functionality, we cannot put the whole, I mean, ideally the data, it is there. The reality of putting this data into an online tool is a challenge. So we have been playing a bit with the capacity. So putting, for example, all the years, but some of the information not, or subseasonal, which takes much more computational and resources and space than, for example, is not fully available. This is one thing, allowing the user the capacity of going back. Then the other thing is once you get this and you go to the detailed panel, and then you go to the advanced part, there was this second part of this advanced panel. And here what you can see is for this particular period, so this is for June, for each of the years, 2017, 2009, 2014, you can see which were the probabilities forecasted. So for example, for 2011, very high probability here. And then you see the observed based on era 5. So you can have an idea of which was the most likely category and where the observations fall. So this is one of the measures that we were doing for people to be able to see. One of the typical ways of doing is if you have a particular year that it resembles a lot 2, 3, or 5 years ago a situation, you can go to that year to see a bit what happened. And finally, as I was telling you, there is this idea of being able to download data, request data, and be able to play a bit more with the data in order to know if you can trust or not this information. In general, there is a final part that I have been somehow indicating or explaining over the explanation, is one of the key aspects for any online tool. I mean, it was key for this one, but it is key for anything that you are designing to provide information online. It is key to make a progressive disclosure of information. So we should be able to provide the person that arrives to an interface first an easy way to read information, not going further. And then, like, for example, so you get this, okay, this is quite, I mean, it's not the most simple interface. You have different sizes, but at least you see the colors and you know what colors means. Then you can go to a place where you have information when you get a bit more detail, and then you go even further into this information. And this is one of the key things that we have learned over the process. The first time that we were showing the prototype, even highly advanced people or users like energy traders, they were like completely pushed by the amount of information. And they were like, the first feedback was, okay, this is too much information. The reality is that once you make this introduction, you spend 10 minutes explaining the tool, then the next feedback that we got was, oh, that's interesting, but I would like to, could we see this additional information? Or could you add, please, the show climatology line? Could you add, please, some information about the now, about El Nino? Could you? So we have to understand that any tool and any online tool that provides visual information, it requires some learning time. We have to be very aware of the cognitive load, or how much it takes for someone to understand and read all the information. But then we need to be able to go deeper later in the information as the user gets used to the interface. And I make a pause here. I don't know if there's any question.
Yes, Isa, we have a general question about how many people is needed to make a tool like this, and how much time do you need?
Wow. I mean, this in particular, I mean, it was an H2020 project, and it was a 3 years project. It took 18 months. The first 18 months of the project, it took to make this tool. And we could do it, and I think it's record time. It was really fast, and we could do it because we were coming from this tool, this initial tool, and we already had a lot of feedback from users. But in general, I think it was like around 1 year, only the part of defining which from the initial tool that we had, which was the information that we had to add, how we had to change it, which was the functionalities that were here. This was a semi-operational system, so you just clicked in one place and you got the probabilities and the skill, and that's it. There was no more interaction. And we were testing, we were doing usability tests about with users, and then we found out that really some parts were not being understood well. And then, yeah, I'm getting a bit lost, but I think it was 1 year defining everything, and then 6 months like implementing the tool to have it launched.
Yes, exactly. Yeah, please go ahead.
Yeah, and yeah, I mean, in general, I just wanted to have a final remark, is that, well, visualizations tools, they are cool. I really like them, and we enjoy doing them. And it is really a game changer. When you have a visual tool, maybe this tool at the end is not providing exactly all the information that was expected. It has to be improved. But it really changes the capacity you have to engage, to start in a conversation, and to start a conversation where you really get information of what you are not providing that could be really useful for a particular user. So it is very important to have them, but of course there's much more. And in the field of climate services, it is not only about providing a visual tool, it's also about putting the experts in contact with the users. So for example, like this webinar we are doing. In my case, I'm more on the communication side, but I was saying at 12, there is this presentation of the forecast. And there, most of the questions are technical because there's a lot of people who need to understand in detail what you are providing and how. So having these open channels of communication is really important. Then we provide these monthly outlooks. And I think it's also, sometimes we think about cool visualization, interactivity, but some people only want a PDF that they can just take a look and spend 1 minute to check if there's a strong signal in something that they should be paying attention. Then regarding this part of creating trust, there is this definition of case studies. So what is, go to a relevant case, so I can go there. So go to a relevant case in the past that is in the memory of this user. So for example, there was this wind drought in USA in 2015. And of course, in Europe, there are many companies that they have wind farms in USA. So really understanding what happened with that wind drought, understanding which were the climate conditions, and then what is particularly useful is to provide, okay, what could have this forecast have tell you? Could have the forecast been able to forecast what was going on, what not? This is really important. And of course, if you know, explaining better which were the drivers of the event, for example, this is really useful to start having this conversation. And so you have a number of them. So right now there's a whole deliverable with a lot of information, but these are the ones that we will explain in a bit more in detail with a more user-friendly image. And then, of course, there are the technical reports. So you can have in the website of the project, there is packages, methods that are open, they are published in papers. So for those that can't really manage information, what we were doing, because I was not explaining at any moment, but sorry. No. I can hear. So what we are providing is here for subseasonal. We are using the ECMWF extended range forecast, and for seasonal ECMWF system 5. But we are not just putting them directly. I mean, we are providing a service, and the service is also how to bias correct, how to improve the information, in some cases, how to provide indicators, so not the direct variable like wind speed, but capacity factor, wind capacity factor, how to provide energy demand, etc. And so all these methods, this is something that is public, and it's part of the service that is being provided. And this is in general, and I wait in case you have some questions. If not, yeah, I can always find things to tell you.
Thank you very much, Isadora. And yes, we do have questions. So let's start from the first one, which is asking, is it planned to have forecasts updated more frequently, like each European Center and GFS run?
Mm-hmm. Yes, it is, but the point is S2S4E is going to finish at the end of this year, in December this year, and up to now the tool is for free. Because this is for research, then we have access or free access to the data, but it is provided with a delay. So we are providing the seasonal forecast at the half of the month. Then the idea after the project is to keep the tool running, but of course for doing so it has to become a commercial product. It has to have some revenues in order to be able to sustain it. Once there are clients or there's people who can really interested in this service, then it will be possible to be able to pay for the forecasts that are available at the beginning of the month. So ideally, yes, at some point next year, we would like to see the tool providing the forecast almost once the forecast is out, with 1-2 days of delay of all the processing of the data.
Yes, exactly. And the case, it would be at the beginning of each month, we'll have the newest seasonal forecast, and twice per week the sub-seasonal forecast, potentially starting from next year, 2021. Thank you, Isa. We have another question. They're asking, thank you. I like the tool. Great. This is more general, but how do you collect information about what user need? How do you know what's useful for them?
This is what we do in our team at BSc. So this is usually, we call it user engagement. And there are many ways. First is going and being in conferences, in sectorial conferences. So being in Wind Europe, being in the places where people in energy is, so you can really engage in a conversation with them. So you can show what you are doing, and you try to have a talk or poster session, but also just being there and talking in different stands. So first is understanding which is the discourse going on in the sector and being in the place where energy stakeholders are. Then workshops, for sure, having interactive participatory workshops where you really ask questions and you try to get as much information as possible. Then interviews, specific interviews. In S2S4E, we had a round of interviews to energy stakeholders to know more specifically their needs on timing, which type of information. Then, of course, more wider surveys. Sometimes they are useful. And then a lot of one-on-one. A lot of people. So, for example, here you see in the tool, your feedback help us improve. So if you click here, then people can give you information on bugs if they find a problem in the tool, but they can also contact you. I don't know. And in many cases, it's just when someone is really interested in the tool, they engage talking with us on emails, then we make a meeting, and that's the way we learn. We learn a lot on this one-on-one basis.
Thank you. And we have another question. This may be for Andrea. And we have been asked from Jan. Have you adjusted the 30-year history to recent climate change?
Hi, hello for the question. No, so there is not a trend adjustment. So all the probabilities that are given, all the thresholds for categories are based on the hindcast period of each model. So if there is a climate change signal there, then it's the reality. So it's what we're going to see. So our probabilities are based on the last 20 years with no adjustment, just with the real data of those 20 or 30 years.
Thank you. And also one more question from Arun. Is asking, as all empirical predictive models still having some lacks at the moment of predicting outputs caused by other natural factors as natural hazards. The question is, could we have the possibility to introduce inputs as wildfire, floods, droughts to predict to predict the post-climate condition?
So I'm not sure about the question. So what's represented in the predictions comes from the Earth system models. So whatever is represented in these models in terms of past soil moisture, ocean, so everything that's included, that is represented, could be there. So for example, if there has been an episode of drought, because of that imprint in the soil moisture, that will be accounted for in our future predictions. But if it's something like a volcano or something that cannot be included, then not. So in a certain way, some things are taken into account if they are represented by our system models. Not sure if that answers if the question was along this in this direction.
I think it was answering exactly the question. If not, please, Aruna can follow up. In the meantime, we can go to the next question, and from Jagdi. Amazing job. You said that in the future you will pay for the forecast if you have enough clients. So you don't have access to ECMWF products. Are you using Copernicus platform as everyone can do?
Mm-hmm. Yeah, so I can access. The point is, if you want to provide this as a service, for sure you have to provide the forecast as soon as it is available. So it is not an option. As a commercial product, this needs to have the latest forecast sharp as they are out. Right now for research, what we are using is this delayed information that it appears at the half of the month. But just because this is an operational tool, it has been operational for a year and a half, but the idea was also to learn. We have learned a lot about how to put all this data streaming, how to make this with a normal performance. You have seen sometimes some delays on information, but with the amount of information that is behind, we have been learning a lot about this. And so, yes, in the future, for sure, it will have. And right now, it comes from Copernicus. Yes, it does. And also the subseasonal, it comes, then Andrea maybe knows better how to explain, but is from the S2S initiative with the real-time pilot. So it's for this specific initiative that we get the subseasonal from ECMWF. Before, a few months ago, we were providing, instead of ECMWF, we were providing in CFS version 2 because it was free and available. But there were some problems, and we had a lot of feedback that it was a bit strange to move from subseasonal with one system to seasonal to another one. That could bring inconsistencies in the patterns, and that's why we were making a strong effort to get the S2S information in the tool. I don't know, Andrea, if you want to add something or.
No, yeah, everything you said is correct. Yeah.
And we have a follow-up from Powell, who's saying thanks for answering the question, and is then commenting that is a trader, therefore it's a must to. It says that for them it's a must to have the forecast on time. If I may follow up on this, yes, we're aware, as we are working with energy traders on a daily basis, and we are also having actually the last webinar of the day is going to be oriented to the energy markets, especially the Nordic market. And yes, we are aware of this. This is, for now, we are in the research part in the project, so we are on the research side. But yes, the ultimate objective is to have this tool up and running after the project, and at that point with client it will be possible to have the information timely and usable operationally for also for trading decision making. And I don't know if you, Isa or Andrea, want to add anything on this point. If not,
sorry.
Sure.
No, I just wanted to add that, in fact, Ilaria is highly involved in this. We are working on economic assessments as long as we can with the difficulties it takes. But in a few months, towards the end of the project, we are doing this effort of providing all this information of what is useful, not even on the energy trading perspective. So we are aware of this, but we will try to share as much of what we are learning on the project.
And thank you. Another question is about the outlooks. So why are the outlook reports available only for European domain? Are you planning to extend it to other countries all over the world?
We have received feedback that they would like to have outlooks for the United States and from other regions. It was a matter of we wanted to show the concept that the outlook and provide it, but also is the amount of time available that we have for this, and that's why we decided just to move to stick with Europe, because the project is paid for the European region, and because once the forecast is out, we want the outlook to be out that same day. That requires quite I think at least 4 people working that same morning on analyzing the patterns, if there's something relevant, writing the text, preparing the outlooks. Then we can do this for Europe. If we had to do also for United States, it would require more people, because you want the forecast, as an energy trader was saying before, you need to have it fresh out exactly when you upload the forecast. But yeah, we know it is something that it could be really interesting, and all this feedback we just note down, and we hope, if for us, I'm part of the coordination team of S2S4E, and I'm happy with what we have done. Only what we have learned on the research and the applied part is really a success as a project. But for me, it could be even a greater success that at the end, this is useful in the future. It becomes a commercial product, and if it doesn't, at least that the lessons that we are learning in the project really help next products to be better.
So thank you very much, Isadora and Andrea as well. We are approaching the end of the session, so unless you have any concluding remark, I will thank you, Isadora and Andrea, once again, and all of you for attending the webinar. The recording will be available. Isadora, do you want to comment?
No, sorry. I just wanted to leave this slide.
Thanks. The webinar recording will be available on our website, and you will receive also in your inbox, together with the presentation and some additional material, plus a survey that you find here in the chat, and you'll find also in your inbox. It would be extremely helpful if you could participate into the quick survey. And I hope to see you all in 1 hour for our next webinar on climate forecast for the summer season. And also this later on at 1:30, we have Nordic energy market summer outlook. I hope to see you later, and thank you once again for your active participation.